Okay, I'm taking a gamble here and assuming that we're going to get through this page in class tomorrow. So first of all, I just want to summarize the derivatives that we know. Besides the power rule, the product rule, and now the quotient rule, is we also have our trig derivatives. And so just a little reminder, this means the derivative of sine of x is cosine of x. The derivative of cosine x is negative sine of x. The derivative of tangent x is secant squared x. The derivative of cotangent x is negative cotangent x, negative secant x tangent x. Sorry. No, that's not right. Gosh, dang it. The derivative of cotangent x is negative cosecant squared x. Sorry, I wrote them in the wrong order than I normally do. The derivative of secant x, this is what I was trying to take the derivative of, is secant x tangent x. And the derivative of cosecant x is negative cosecant x cotangent x. What I was trying to show you here is that, one, you have to memorize these, but two, when I look at these, when I remember these, I remember tangent and secant together because their derivatives are in each other, and cotangent and cosecant follow that same pattern that secant and tangent do, only they're the other functions. The other thing I want you to notice is all the functions that start with the C, cosecant, cotangent, and cosine, their derivatives are negative, so that's something else to remember. But maybe start practicing these because there's going to be a quiz eventually. All right, so let's go on and do a couple more of these in hopes that we can get through this in not too much time. So on this one, if I do the quotient rule here, because that's my only option, because I can't simplify that. So if I do the quotient rule, I'm going to take the derivative of the top, the derivative of sine is cosine, times the bottom, which is 1 minus cosine theta, minus the derivative of 1 minus cosine would be negative sine, right? Oh, because it's already a minus. I got it here. This is where I messed up yesterday. So minus the derivative of negative cosine would be positive sine now, right? Times the top, which is sine. So simplifying this, I get cosine theta minus cosine squared theta minus sine squared theta, and I hope you notice I forgot the denominator squared, over the denominator squared would be 1 minus cosine squared theta. And I'm not going to work that out in the bottom, at least unless I have to. Can I simplify any of this? And would you be expected to simplify any of this on an AP test? I don't know. But looking at this part here, sine squared plus cosine squared equals 1. So like technically on this, we could factor the negative out of this, and we'd have cosine squared plus sine squared. So just to kind of remember that that would be cosine theta minus 1 on the top. And so if you really want to be fancy here, you could simplify this on the bottom. That would be 1 minus cosine times 1 plus cosine, because you could factor that. Oh my gosh, this is crazy. Almost there. I could almost cancel this out except for I need a negative, right? If I take a negative out of this, that becomes 1 minus cosine on the top. And I get negative 1 over 1 plus cosine. I think this is a bit ridiculous that they expect us to do all this right away, but I'm just showing you, okay? I didn't write it. Look at the next one. Again, we could jump right in, but if we can simplify, we want to do that first. So the first thing that I would do on this, without changing it, I could, to get rid of this fraction on the top, I could multiply the top and the bottom by x, because x over x is really just 1. So if I do that, I would get 3 minus 3x minus 1 on the top. Do you agree with me on that? Because the x goes to that, then the x cancels out on that one. And on the bottom, I would get x squared plus 5x. And I don't know about you, but that looks easier to me to take the derivative of as a fraction. Okay? So you have to know the quotient rule. So I just remember the derivative of the top times the bottom minus the derivative of the bottom times the top all over the denominator squared. And maybe since I forgot that last time, I'm going to do that first this time. X squared plus 5x squared. And on the top, I'm going to take the derivative of the top, which is just 3, times the bottom, minus the derivative of the bottom, which would be 2x plus 5, times the top, which would be 3. Now again, how much do we have to simplify? Like the one over here, are you ever going to have something like that you have to simplify on a test? No. On this one, if this was a multiple choice question, they're going to at least simplify the top, okay? A lot of times we don't do anything with the bottom unless you can cancel something out, like on the last one. But I'm going to distribute this. So I'm going to get 3x squared plus 15x minus 2x. Oh, not just minus 2x, right? I'm going to do this all at once, okay? I'm going to distribute this, so that's going to be minus 6x, and 3 times 5 is 15, but I have to distribute that negative, so it's going to be minus 15. So I think I get 3x squared plus 9x minus 15 on the top. And yes, I see that there's a factor of 3. If you want to factor it out, you can. I'm just going to leave it. I at least did some simplifying. What do you think about that? I don't think there's anything that cancels out. All right, so let's look at a few more. Where's my time? 6 minutes. Okay. Below is a graph of a function f of x, and let r of x equal cosine of x divided by f of x. Is the graph of r of x increasing, decreasing, or neither increasing or decreasing at x equals pi? Show your work and justify your reasoning. Well, if we want to talk about increasing and decreasing, we want to talk about the derivative. Yes? So the first thing that I'm going to do here is I'm going to take the derivative of r of x using the quotient rule. So the derivative of the top, derivative of cosine is negative sine times the bottom, which is just f of x, minus the derivative of the bottom is f prime of x times the top, which we're not going to touch, which is cosine, all over f of x squared. And now I'm going to plug pi in there. So r pi of prime is going to be negative sine of pi times f of pi minus f prime of pi times cosine of pi over f of pi squared. How are we going to find f of pi by looking at this? Well, we can at least figure out if it's negative or positive, right? So what do we know? Let's clean up what we can clean up, okay? Sine of pi is 0. So 0 times this, that's just 0, right? This is just 0. So I have 0 minus cosine of pi is negative 1. So that actually is just going to become positive f prime of pi over f of pi squared. Like that. So f prime of pi over f of pi squared. Well, what do I know? I know that the bottom of this is always going to be positive because it's squared. So all I have to determine is what's happening at pi for the derivative. So if this is the function, right? Let's go back here and make sure it's the function. This is the graph of f of x. Pi is roughly like right here. What do I know about the slope of that line? I know that f pi of prime is less than 0 because f of x is decreasing at x equals pi. And since f of pi squared is going to be greater than 0, then r of x is decreasing at x equals pi. Right? Because the bottom's going to always be positive, but we know the derivative there is going to be negative. What do you think about that? Okay, and then with the table, and so I'm going to do at least a couple of these, and then I'll stop. We'll probably do the last one together. But again, given a table, answer the questions. This is just like what we did in class on Tuesday with the product rule. If I ask you to estimate a derivative, using a table, I just have to find the slope between the points near it. So 2.5 is right in between 2 and 3. So I'm just going to use the points to find that secant line, right? So I'm going to take the y's on the top, -3 minus -1, over the x's, 3 minus 2. So I'm going to get -2 over 1, or g prime of 2.5 is approximately -2 using the secant line. Look at the next one. It says, if p of x equals g of x over f of x, what is the value of p prime of 4? And what does the value say about the graph when x equals 4? So again, looking at this, I need the quotient rule because it's a quotient. And I'm going to try to be productive here and put 4 in here. So the quotient rule says the derivative of the top times the bottom minus the derivative of the bottom times the top all over the denominator squared. And again, I just plugged 4 in there because 4 is my problem here, yes? And then I just use the table. So p prime of 4, g prime of 4 is -2, f of 4 is 1, f prime of 4 is 8, g of 4 is 7, all over f of 4, which is 1 squared, right? So I think I get -2 minus 56 over 1, or -58. What does this tell me about p of x when x equals 4? Well, if my derivative is negative, then I know p of x is decreasing at x equals 4 because p prime of 4 is less than 0. Same description as always, but now we can just do the quotient rule. And so there's 2 more problems here. I know they're a little bit complicated. Maybe at least the bottom one. See if you can at least get started on this. This one's kind of crazy. This one's like product rule and quotient rule together. So maybe we should save that one. But see if you can do this one down here, okay?